First, I will be going over a quick example on how we're going to do it in MIDAS. So this is just from a regular concrete textbook, and we will do this retaining wall problem here. So we have these dimensions here, we have some surcharge, and we have our lateral earth pressure. And I will be showing mainly how to verify the moments, the forces, and also maybe in a separate video, I will be showing how we can check the factor of safety against sliding, against overturning, and also how to design the stem and also design the heel and the toe of the retaining wall. And we can compare our answers to the answers that are here. Okay, now let's move on to MIDAS. Now when we open MIDAS, we will click New Project, and this is how it shall appear. The first thing you want to do when you create a new project is first, let's click Save As, and we'll save our file. So let's just call it example4. Saved. And now the other first thing I like to do is change the units to whatever units we will be using. So our problem, it looks like they do pounds and feet. Let's go to pounds, feet. Also, the other thing that I like to do is add the second tree menu. Usually it's not there, but you can add it by just right-clicking here and adding tree menu 2. This will facilitate the workflow after, and I will show you why. Okay, so first let's create our nodes based on our dimensions. So we have a footing that is 11.5 feet long. Let's draw that first. We'll go to nodes, create nodes. We will make the first one just at coordinate 0, 0, 0. Apply. Now, we can create the node manually by putting the coordinate, but I like to use translate. So we'll use translate. We will select our node by using select by window or select by polygon. This one just selects a polygon. This one just selects a window. And this one just selects by the arrow. I just like to use Control-Shift-S, and that'll just do the window. So we will highlight our node, and it is 11.5 feet away in the X direction. We'll click Apply. Okay. And actually, before I move on, let's just go to Structure, Structure Type, and since this is a 2D model, let's just change it from 3D to XZ plane. Now that we have that, let's move this here. We can see the two nodes here. Our sketch. Let's also do these nodes at the beginning of the tapered wall, at the end of the wall, and also at the top here where it begins to taper. So this one is 3.75 feet away. This one will be 6 inches away from this point, and then this node will be 1 feet away from this node. So Control-Shift-S, highlight this node, translate, and the first one, like I said, is 3.75 feet away. There it is. The next node, which is the taper, from here is 6 inches away. So 0.5 feet. 0.5 feet. Then the back of the wall will be 1 feet away. 1 feet. Control-Shift-S, highlight your node, apply. There we go. So now, if you want to measure the distance, if maybe you made a mistake, you can do that by clicking F4. Just close this. F4. This will pop up, and you can click your first node, your second node, and I'll tell you here, 3.75 feet distance from node 1. You can go from here to here to double check, 0.5, here to here, 1 foot, from here to here, 6.25. And does that match? Yes, it matches. So now we want to do the top of the footing so that we can draw a wall only from the top of here. So we will make a node, a vertical node, 1.5 feet above from here, and then another node, 19.5 feet from this node. I think this picture shows better, yes. So this one here will have 1.5 feet above, and then 19.5. The wall, that's this node. Translate in the vertical direction, 1.5 for the top of the footing. There it is. And then from here, 19.5. You can recenter by clicking here. And now we have our nodes. Now we want to create our elements and actually make it into a 2D model. So the first thing we want to do is go to Properties. Let's define our material properties. And the problem actually, it tells us that we're using 3000 psi concrete. So let's use that. We'll click Type is concrete. We'll go to Standard ASTM. And let's go with 3000. The name will auto-populate here. All the properties will auto-populate here. We'll click OK. Click Works on both sides. This is where all your information about your model will show up, and you'll see here that grade 3000 has popped up for the material. So next we'll have the section properties. Add. And we will define two section properties here. One for our footing and one for our tapered stem wall. So first, let's do the footing. We'll name it footing. Footing. It's just going to be a solid rectangle, and since we're going to be designing per foot basis, we will just make the width 1 feet and the height, which is 1.5 feet. You see here it says section input data contained errors. I forgot to calculate the section properties. So just make sure you click calculate section properties. Now we have that there. We'll click OK. So now that we have the footing, let's draw our footing. We'll go to create elements. You'll see here that the material name and the section name will pop up here. So once we do the wall, we will need to change it to the wall. So first let's draw the footing. From here to here, there's our footing. And if you don't have the 3D mesh on, you can just do that. You can click here, Control H. It will hide it and unhide it. I like to have it on. And as you can see here, it kind of draws it at the center of the nodes. We want it at the bottom. We want our node to be here and the footing to be above the nodes. So we can do that by right-clicking on our section that we just created. Go to Properties. Change the offset from center to center bottom. Now it's above. And the other node that we created here is right exactly at the top of this 3D shape. So now let's draw our wall. We'll go to Properties again, Section Properties, and we will define our wall. We will do a tapered section. We'll go to Solid Rectangle again. Let's just name it wall. And at the top, right, we have 1 feet. At the bottom, we have 1.5 feet. Top, let's do 1 feet. Again, we're designing per foot basis, so 1 feet. The bottom 1.5 and make it 1 feet. Here, well, let's keep it center to center now, and I'll show you how we modify it so that it looks exactly like it does in the sketch. So click OK. Now it shows up here. It shows up green because we haven't defined a section that has that yet. So we'll go to Node Elements, Create Elements. We have our material again, but now we need to click Stem Wall, and now we need to connect it from here to here. As you can see, it tapers from the center. We only want it to taper at the front. You can do that by doing the same thing with offset. So we'll go to Properties. And you can play around with this sometimes. Sometimes you won't get in the first time, so let's just try center top. Let's just see if that fixes our so there, it fixed it. And let's just look at it in 3D. Yep, there it is. So center top. Sometimes if you do the element from the bottom to the top, it'll create the tapered section in the opposite direction. So if you want to fix that, you can delete the section and just redraw it by starting with a node from the top to the bottom. Now we have our sketch. Now we will move on to how we apply the loads, how the program can automatically apply the self-weight, because that's the first thing that they do, the weight of the footing and the weight of the wall, and then how we can apply surcharge, the lateral earth pressure. Okay, so on to step 2. Now that we're going to be looking at our loads, let's just do something real quick before we apply the loads. Let's apply our boundary condition. And in our problem, we can see that first we're doing the factor of safety against overturning, so that we will need the moment to be about the toe. So we will create a boundary condition right here, right in the front in our model. We'll go to Boundary, Define Supports. You can make it fully fixed, but since it's a 2D model, let's just make it restrain it in the X, in the Z, and then our moment in the Y. We need to click this node, Control-Shift-S, and now click Apply. And there it will show up. Okay. Now let's go on to our loads. And first, let's do the dead load. This the program can handle for you. So we'll go to Load, go to Self-Weight, And here we'll have an empty load case. Again, if it's empty, let's define it. So you can click the three dots here, or simply click static load cases here. First, we will do the self weight. So SW, and this is a dead load. See, it shows up here now. And for the program to calculate your dead load, you just want it in the gravity direction. So just make a Z -1. Z is our vertical, like I mentioned before. So just make it -1. Click add, and it'll show up here. Okay. In the hand calcs, let's start checking, before we do the full model, let's just start checking the initial load. So let's start just checking the dead load. Here they have the weight of the footing, the weight of the tapered portion, and then the portion that's just 1 feet. So this W1, W2, W3 should match our reaction in our model. So let's just run it before we apply any other loads, just to check this one case. We'll click here, run, or F5. See, there's actually some errors here. See, note 6 and 7, and I'll show you why. Because if you click Control H, it's actually not connected here. So we need to add a rigid link. Because if this was to go all the way down, right, we would be taking into account the concrete weight twice. So we just need to create a rigid link, and we do that by going to boundary. Let's unlock our model here. We'll create a rigid link. You can either do a rigid link or just an elastic link here. In the type, just click rigid, and then you click your 2 nodes from here to here. It'll say will be deleted. Yes, that's fine. And now we have a rigid link there. Now let's see if that works. Okay. There's no more errors now. Okay. So to check our reactions and verify our results, verify our hand calcs, we'll go to results. We'll click here reactions. We'll show up our load cases, which is just the dead load right now. We'll click FZ. I'll show the arrow, but we want to see the values and the legend. Click apply. And if you don't want it in scientific notation, just simply click the 3 dots, click fixed here. Now it won't show up, it'll show the max reaction, and the value here will show in the arrow. Let me go here. So 6243.8. Let's see how that compares with the problem here. The total dead load here is W1, W2, and W3. So if we add these 3, it should give us that. So let's just check that. Calculator. 2088 plus 731 plus 29, 25. 6244. Very, very close. Very close. So you see, that's how we verify that our model is working and it's acting exactly how we want it to act. Okay. Step 2. Let's move on to our other loads.